So welcome back. Close enough to 3:40 to get going. So I was moderating the track. Now I'm presenting in the track. My affiliation, please note the non-official. I'm sure I will be chastised for that because that's probably not the brand. So through fortuitous coincidence, I think, the three sessions of this second half of the track, at least, I think we're all arguing the same things, and we're all somewhat agreeing with each other. Somewhat coincidental, I think. So I'm going to talk about onboarding, what I'm calling onboarding, which is somewhat what Carl was talking about when he was describing the registration of devices. And I'm going to argue the importance of IAM in the smart home, which was what Robert was talking about. So hopefully with this repetition, maybe we'll convince you. And I say it's onboarding in the IoT, but to be honest, you know, it's a specific corner of the IoT, smart home. As important as that is, I wouldn't argue it's all of the IoT. It's not wearables, it's not industry, et cetera. So with that caveat, here's my definition. In the enterprise, onboarding typically refers to provisioning a user with some credentials. Hire an employee, give them an Active Directory credential, set them up in the appropriate applications so they can start to do their work. Two aspects of right. There's an authentication component. There's giving some new actor, some new client or a user or an employee some new credential that they will use to authenticate to systems. And the second, arguably more important part is setting up the authorizations and permissions against that credential. And we need both those pieces before that actor can start doing work, whether it's an employee logging into the various systems or some new thermostat in the home. And kind of squinting a little bit and stretching the definition, bear with me, I'm going to argue that there's different flavors of onboarding in the smart home, but they all share that basic aspect of something a priori unknown is brought into the house or brought into the ecosystem of the house, and we need to do the same two things. We need to give it a credential, and we need to define appropriate permissions. Now, in the enterprise, those permissions are set by IT based on corporate policy. In the smart home, those permissions ultimately should reflect that of the homeowner and the people in it. So it's more of a consent operation than an authorization step. Sort of representative use cases, device to device. So Carl talked about how you can leverage BLE to get two devices to recognize each other and ultimately be able to securely interact with each other. I'm going to focus more on Wi-Fi, the challenge of bringing a device into the home and getting it onto the home Wi-Fi before it can do anything else. Related, house guests. They're coming into your home. How do you give them Wi-Fi access in a manner that's secure and appropriately permissioned? Once you've got a device on your Wi-Fi and so connected to the cloud, how do you bind that device to some cloud account, either at the service provider that manufactured it or in an ideal world, an arbitrary service? And lastly, how do you do the same thing between applications? How do I provision one application with credentials and permissions against another? The last, I think, is where we have made the most progress on the web. I mean, that's delegated authorization, that's OAuth 2. We understand that, and it's working for us. I think the opportunity and the challenge is to apply the mechanisms of the fourth to these other three. And that's the work that needs to be done, I would argue. So clearly how you provision some actor with credentials and how you set up appropriate permissions is a pretty critical step in the life cycle. If we don't do that right, then everything else will be similarly disabled. So the normal weakest link argument. And I would argue that the qualities of this onboarding mechanism, somewhat arbitrarily picked 4, are the same for all of those different flavors of onboarding that I showed earlier. Clearly, we want it secure. We can't have a man in the middle eavesdropping on that process of issuing credentials and grabbing those credentials and using them inappropriately. In the smart home, we need this to be usable. If smart home is going to see any sort of adoption, we need homeowners to be comfortable and familiar with the mechanism of bringing something new into the home and setting it up. Because if they aren't, it doesn't get used and adoption doesn't grow. Granular. We need the mechanism by which we differentiate one device from another to be appropriately granular. It can't be just yes or no, I can get on the network, or I can access my health data, yes or no, right? We need granular permissions, granular consent, like we're starting to see on the web. And lastly, interoperable. If this is to scale, if we're ever going to break out of the current default of silos in the smart home where one device talks to one cloud, then we need credential provisioning and onboarding mechanisms that can work across different platforms. So the first, device to device. And as I said, I'm going to focus on the challenge of getting an IoT device onto the home network, which at least currently is the challenge of how do I get it onto the Wi-Fi router. So there's a bootstrap problem, right? And it's similar to all 4 flavors of onboarding. Something that a priori is unknown and untrusted has to somehow have its trust elevated through the intervention of the homeowner in these scenarios into something that is trusted and appropriately provisioned. And the challenge for IoT devices, more so than laptops and phones and any other Wi-Fi client, is of course that these are headless, or oftentimes headless. They don't have the same UI mechanisms by which we can expect the user to help us with the provisioning of those credentials. So lots of different ideas are being experimented with in order to circumvent this limitation. WPS has been around for a while. Security issues with at least one manifestation of it. I've seen it being deployed or leveraged for IoT devices. Device hotspot seems to be the current preferred model, whereby when you bring a device into the home, turn it on, it sets up its own Wi-Fi hotspot. You connect to that. Through that connection, you provision the actual password of the real Wi-Fi for your house, and then it shuts down the first network, theoretically, hopefully, and you're good to go. Others, there's a variety here, which is problematic in its own right, because for a homeowner, if they bring in one device, they might be presented with one ceremony, see something very different for the next device. So there's a usability implication there. So how are we doing? The hotspot mechanism, at least some implementations of it, not particularly secure. These light bulbs could be tricked into turning on that initial hotspot, and if an attacker was able to be in sufficient or reasonable proximity, they can intervene in that process, inject themselves into that process, phish the homeowner when the homeowner presents the actual Wi-Fi credentials, and they're on the network. Or proprietary, the smart config mechanism from Texas Instruments does something admirably sneaky in that it provisions the credentials over an encrypted network for which it can't actually decrypt the packets, but it encodes the actual Wi-Fi credentials as the length of UDP packets, and thereby, through this proprietary kludge, is able to send over an encrypted channel the actual Wi-Fi credentials. Elegant, perhaps, but not interoperable. or weird, right? Just leveraging different display mechanisms and other channels, right? If the device doesn't have a keyboard and a screen, how else can we push that information here? This one uses light pulses as the way to do that. Again, a solution to the problem, but one that probably is not going to achieve the ubiquity that we need if we want homeowners to be able to consistently perform this. So a report card. I don't know, we can argue over any of these. I'll highlight granularity because all of these are binary. I'm adding the device or I'm not adding the device. There's no inherent mechanism by which I can differentially authorize those different devices. You're on the network or you're not. Usability, you know, they may be good or bad individually, but there's so many of them that we can't expect users to be able to confidently take on any of these. The second category, users, device to device. So this manifests as someone's coming into the home and you want to grant them access to your Wi-Fi. Now, typically it's, well, not typically, inevitably it's going to be through some device that they have. So this is probably the current state of the art, right? These elegant little photos that you put on your front hall and broadcast the Wi-Fi password. Kudos for the length, but perhaps not so secure. I tried something different. I've been trying to force my family to use to Slack. It's a failed experiment, but I set up this Slack bot, recently updated the password. Kids don't want anything to do with it. The Wi-Fi hubs themselves are adding capabilities around this use case. The modern ones, Google's OnHub, what's another one? Almond is another, whereby via the hub or through the administrative features of the hub, there's something more elegant to distribute the Wi-Fi password to your house guests than writing it down on a piece of paper and handing it to them. So that's, I would point to this as an encouraging sign, right? Where the hubs, the Wi-Fi hubs in this case, but hopefully routers, or sorry, IoT hubs in the future, start to acknowledge the value of more intuitive, more usable onboarding mechanisms and ultimately differentiated permissioning as an example of more hubs having, you know, a guest network. So you're still sharing a password for a Wi-Fi network in your home, but it's not the Wi-Fi that you use. It's one with differentiated permissions, you know, maybe not access to all the drives, more appropriate to those that you invite into your house. So another example of IAM capabilities starting to emerge in these hubs and routers. But both those mechanisms for provisioning a device or provisioning a thermostat with your Wi-Fi credentials or sharing your Wi-Fi credentials with house guests, they both, you know, they both sort of encode the password as the means and mechanism for authenticating to Wi-Fi. And we know the issues with relying on passwords as the primary authentication credentials into applications, or in this case, devices and servers. So it's more of the password anti-pattern that we've been slowly trying to get away from on the web, albeit without at least the risk of breach of some large database of passwords. But still all the negatives over the inability to define granular permissions. It's still phishable. If you're relying on a password, you know, your user has to present it somewhere. That can be phished. There's this implicit drive to discourage the user from picking a strong Wi-Fi password because they know they're going to be printing it out and sharing it, and they want to remember that. And it's hard to revoke. If I give Carl my Wi-Fi password, which I would never do, he's going to know it, and he's going to have it unless I change that, and that's going to impact everybody else that I might have given that to. So here's an example of another trend in the Wi-Fi routers where we can do something better than passwords, right? We're sending an E-key. I think this is for a smart lock. So different twist on the use case. So this is, rather than setting up an absolute permission for a given user to be able to open the lock on the front door, we can define and set up constrained permissions. So again, I see this as an example of the types of functionality that we need to see more of. I think we're doing slightly better here. It's less of a challenge, right? We have a user that can facilitate the provisioning and the issuance of that token. In the worst case, they can type it into their own device. But granularity is still poor because the default expectation is that they're going to get access to the same Wi-Fi network that you as the homeowner use. So we can do better. So device to application. So kind of this manifests for me as as an example, I've brought the Nest into the home. I've gone through the Wi-Fi hotspot trick to get the Nest on to my Wi-Fi network. That's great. But at that point, that Nest doesn't know who I am. The Nest servers does not yet know that I, a given Nest user, have just purchased this particular Nest device, right? There's two identities that we need to reconcile and bind. So that's the challenge, right? We need to bind these two identities and again, appropriately constrain permissions so that that Nest, can do what, or more generally that device, can do the appropriate things that I define. So the current model, arguably the best practice, is that there's two sessions set up. I in an app, so this is the Nest app that I've downloaded. I authenticate in that app. That could be OAuth. Hopefully it's OAuth. Similarly, the device was shipped with some sort of cert, or maybe it's just a key pair. That was burnt in at manufacturer, something that is unique to it. If not unique, maybe it's an attestation type cert, like Carl referred to, where it just asserts I'm a Nest thermostat, if not an individual one. So we can set up two secure channels, and then through some sort of mechanism facilitated by the user, in this case a QR code on the back of the Nest that is scanned by the app, we bind those two channels together, and the server is able to tie those together and say that this Nest is now operating on behalf of Paul going forward. So I'd argue that that's in it of itself is almost an anti-pattern. It's a new anti-pattern. It's not relying on passwords to the same extent. We still have to manage those certs on the device, normal challenges. Critically, it can't support the concept of a device being shared by multiple members because that association is established between a single device and a single user, and that's sort of recorded on the server. So we can't support a really important use case where a single device is shared amongst different users, smart scales, et cetera. And it doesn't inhibit correlation, right? Because if that device is using the same cert or the same private key to authenticate to multiple servers, then those servers are able to, or they would be able to, inappropriately correlate all that behavior. A better model is one where the credentials that are burnt in at manufacture time, the primary credential, that cert, is never presented to actual applications. But instead, we go through an abstraction or an additional issuance mechanism, and we issue tokens that represent the relationship between that device and this user. So in one scenario, maybe the thermostat ships with some sort of attestation that says, I'm a good I'm a good Nest thermostat. That device, when powered up, generates a new key pair. The public key of that is signed by the private key associated with the attestation key, those inevitably stored in some secure container like Robert referred to. And then that generated key pair is used to authenticate to an OAuth authorization server or something comparable, via which the user, through their own authenticated session, something similar to the OAuth authorization flow, is able to consent and give their permissions for that device to be able to operate on their behalf going forward. And that permission represented in the issuance of tokens. So all the advantages of tokens that we see for OAuth on the web, granular consent, easy revocation, inhibition of correlation, just as relevant here. So, so that's the model I'd argue for. I don't think we're there yet, right? I think the default is something closer to that anti-pattern. So we don't do particularly well there. And lastly, the one that I think we have the best handle on, because we've been working on it the longest, is application to application. In the IoT, I think it's encouraging that the default mechanism by which these wearables and smart home providers secure their back-end APIs, perhaps not the API by which the devices authenticate to their cloud, but the mechanism by which they secure the APIs they offer up to third parties is OAuth 2. So Fitbit, Smart Home, or Smart Home as an example, no, Smart Thing, sorry, both secure the APIs out their back end with OAuth 2. So that's an encouraging sign. But just saying OAuth 2, does not guarantee that the permissions are going to be appropriately granular. You can use OAuth 2 and not give users appropriately granular consent over the nature of the data. So I think this is if this then that, accessing smart things. That's a pretty wide open consent page. And it's binary, right? You either buy into all of this or you don't buy into any of it. Notwithstanding that, I think this is where we're doing the best. Reasonably well adopted standard, OAuth 2, additional extensions built on top of that. Security, the issues were in OAuth 2, or the places where we can tighten up security in OAuth 2, we're doing that work, token binding, POP, proof of possession tokens, et cetera. So we're doing better in security. It's a ceremony, I think, that users are accustomed to. That ceremony of being directed somewhere else to give their consent for something to subsequently happen. I think they're accustomed to seeing that on the web and would become accustomed to seeing that in the home. So overall, though, that's not a great report card for where we are with onboarding in the IoT. So summer school, I think, is appropriate. The fundamental problem, I think, with all of those mechanisms and why we had not the same, or not the report card that their parents might have hoped for, is we're trying to use primary credentials, whether it be certs or passwords, as the means by which these devices authenticate to resources. The OAuth model says we trade primary credentials for secondary credentials. And that mechanism of trading allows us to inject the authorization step and to mitigate a lot of the excesses of using primary credentials for authentication. So that's the challenge, I think, is getting away from that model. And if we don't do authentication correctly, then that's a pretty weak foundation on which we try to build authorization. So the opportunity, I think, is to apply that delegated authorization model that we're successfully doing for app-to-app onboarding, but to apply that to all those different flavors of onboarding in the smart home. The coincidence that I referred to, I think I think there's encouraging signs that we might get there. So there's authorization features emerging in modern routers. There's IoT features emerging in modern routers, right? Modern routers ship now with multiple radios and not just Wi-Fi. There's Zigbee, et cetera. There's the IETF ACE working group, which is working to define how to bind delegated authorization, OAuth, to the constrained protocols that devices will speak. They're focused on CoAP, but the principle is going to be true for other constrained thing device protocols. So NAPS, an effort in the OpenID Foundation, effectively dead for its original use case. Is Brian in the room? Thanks, Brian, for killing that. Might be applicable here, because NAPS defined a model where one piece of software was able to facilitate obtaining tokens for a more constrained piece of software. Maybe that's applicable to this onboarding mechanism for devices. And I think we have emerging channels beyond just apps for collecting consent, Amazon Echo, et cetera. Is that a channel by which we could create usable ceremonies, consistent usable ceremonies by which homeowners are able to authorize these devices and these house guests and these things in their home? And that's the goal, right? No failed, no things repeating school like Brian did throughout high school. Thank you very much. Questions?
Thanks, Paul.
Should be.
Is this thing on? Yes, it is. So how much of this do you think is in the vein of transition from software-based solutions to hardware-based? So are we, because if you look at the report card, right, the bottom row, which is software only, was scoring higher because it's more flexible, it can be bigger, less constrained, and you notice that the Wi-Fi routers are getting the capabilities first because there's a point to getting capabilities first. Is that why we see the evolution towards? Is that the path we're on?
So I think we're doing better on the bottom because the security risks associated with what preceded OAuth 2 were more significant, right? We're doing better there because we've had to confront with password breaches and all the associated vulnerabilities of passwords. We haven't faced that pain in the smart home, right? We're not being confronted with smart homes being hacked yet. When we face that pain, then I think we'll be more motivated to consider alternatives to passwords and their current prominence in the smart home or in the dumb home.
Who owns the problem? And what I mean by that is most of these devices don't approach how to attach till they've already built the device, they've already tested it. They're not worried about connecting it. In a lab, they have an open, Wi-Fi and everything. Then, oh, it's time to ship. Let's do this. And most of the technology you did on the report card already existed. So we're trying to bolt something on to something that they didn't even think about in the first place.
Agreed, but I think that was the same challenge we saw on the web. Application developers just did the default, and that was password-based authentication. Pressure from companies like Google for the alternative, and the bad press of being hacked motivated them to move to the new models. I think we'll see the same dynamic.
So I have two questions. First question, any comments on hierarchical IoT? So in other words, oftentimes IoT group together for a particular purpose, maybe for a particular user, and then the parent may be strong initially, but when they group with the child may be weaker, and how do you handle that?
So the question is about hierarchical IoT, and I guess use cases where devices team together to do a particular task.
On demand, yeah.
On demand. That suggests a very complicated consent UI. I don't have much to say. I mean, I think ultimately that depends on the devices being able to authenticate to each other, right? And this model would support a more dynamic-based device-to-device authentication than passwords all over the place, right? Because a given device could authenticate to the home AS in the hub, as Robert described, get a token that represents real-time dynamic permissions, and use that in interacting with other devices. So I think the dynamic nature could be supported by dynamic credentialing.
I guess my second question is, you talk about the multi-user device. So what about a user credential? One maybe they're not equal basis, some may be weaker than the others. So do you kind of do averaging or kind of for the device credential?
I'm not sure I understand the question.
Like smart scale, you just mentioned. You know, you have parents, kids. The kids may be more unsecure because they go out social network and they have different other things. Yeah.
So I definitely imagine that there would be administrative users within the home, and they would be able to define and create accounts for other users and define permissions appropriately, like we do for homes now. Do you have an idea, Carl?
No, I have another question.
Okay. Well, I think, was there a question in the back?
I was going to point out that Internet things devices in the homes have already been hacked. Smart TVs from Samsung, smart fridges, I think maybe also from Samsung, and a lot of those others. Now, admittedly, they're just pure connected to the network directly, but okay. Internet of things devices have already been hacked. Smart TVs are the first example, there'll be others.
So that's a good sign, right? Because that's going to put pressure on Samsung et al. Carl?
The concept of the sort of the temporary hotspot as an onboarding tool, if we generalize that as a concept of let's make ourselves really easy to connect to with very little security, just as a way so we can talk and then do something, are there, you know, do you see that as a useful concept generally, or does it have fundamental flaws, do you think?
So I think if you do that, then you rely on the user to be a more discerning administrator of trust, right? And I don't think we can necessarily do that.
Okay.
And thus the value of attestation to at least bootstrap us to the point where users can't harm themselves, perhaps. Thank you very much.